Hello everyone, welcome to Mifratech. So today in this section I'm going to explain you this long short-term memory, that is LSTM network, neural networks. So it is one of the type of recurrent neural network. It is widely used in different applications. So now in this section I'm going to discuss about what is LSTM, what are the features of this LSTM, and what are the advantages. Again, what are the application areas where we can use this LSTM. I'm going to discuss in this section. So first we'll see what is this LSTM. So it is a long short-term memory networks. Usually we'll call it as LSTMs. It is a special kind of a neural RN, that is recurrent neural network RNN. It is capable of learning a long-term dependencies. Like it can remember the things very long time. So it is capable of learning long-term dependencies. So in those areas it is mainly used, and they works tremendously well on a large variety of problems, and it is widely used now. And LSTMs are especially designed to avoid the long-term dependency problem. So in some of the neural network there is a dependency in remembering. So in order to avoid those situations, this LSTM is designed. Remembering the information for a long period of time is practically that is the default behavior of this LSTM recurrent neural network. And this LSTM networks are a type of recurrent neural network capable of learning order dependencies in sequence prediction problems. So whenever you're predicting any sequencing by remembering the like a previous sequence, this help us to do that one LSTM. And it is a this is a behavior required in complex. So this is the exact remembering the previous sequence and predicting the next sequence is a behavior which is a main important thing in predicting some of the complex problems like machine translation or speech recognition and more. In different complex areas this LSTM is used. Next, what are the features of LSTM? So LSTM is a recurrent neural network architecture that remembers a values over arbitrary intervals. Like I told, it will remembers the values, previous values. And LSTM is well suited to classify, process, and predict a time series given a time lapse of unknown duration. So mainly in order to predict the stock price prediction by remembering the old stock values according to the date, next date what is the stock value, like that. Remembering the time series, it will help us to do that one. And a relative intensity to gap length gives an advantage to LSTM. That is what the one of the advantages of this LSTM. And over alternate there are different alternate RNN and hidden Markov models, other sequence neural network is there. When compared to that one, why LSTM we are using this, because it is able to remember and it has a relative intensity to gap length. That are the main advantages or features of this LSTM. So next we'll see what is the architecture which allows LSTM to remember. What is the architecture of LSTM? See here, this is the exact architecture of LSTM, which has an input gate where the input is fed, output gate where we'll get output, and there is a forget gate is there which help us to remember the things, and input modulation gate. So this is what the exact like architecture of this LSTM. So we'll discuss some more information about this architecture now. See, first the long-term memory, whatever the long-term memory which help us to store that one, we'll usually call it as cell state. So here you can see there is a cell is there. This is what the cell state. So the long-term memory we usually called as a cell state. So the looping arrows indicate the recursive nature of the cell. Here there are some looping arrows is there. Though will indicate the recursive nature of the cell. This will help us to allows the information from previous intervals to be stored in the within the LSTM cell. So whatever the information coming from the previous interval will be stored in this LSTM cell. So the cell state is modified by the forget gate placed below the cell state, and it's also adjusted by the input modulation gate. So whatever the, if some information to be forget bits, that will be made by this forgettation. If you want to do any modification, that can be modified by the input modification gate, this gate. And from the equation, the previous cell state forgets by multiply with the forget gate and add the new information through the output of the input gate. So for these each input output input modulation gate forget, there are some input like sigmoid in functions or cells equations will be there. According to that, the weight will be modified and forgetting remembering things will be happen here. So this is what the cell state I told, right? This one, the cell state equation is below. There is the equation you are seeing, right? This one is the equation of the cell state, and this one right side is the forget gate. This below is the sigmoid function or equation of the forget cell. Here the remember vector, usually the vector which will remember is the, here we'll call it as the forget gate. The output of the forget gate tells us the which cell information, cell state, which information to be forget by multiplying zero position to the matrix, like which information we should forget or which information we should remember. That will be help us to uh, help by the forget gate to do that one. If the output of the forget gate is 1, the information is kept in the cell state. That is what the main meaning of output gate of forget gate is 1 means the information which will help, which will be kept in the cell state. From the equation sigmoid function, it is applied to the weighted input or observation of the previous hidden state. That is nothing but here this equation is there, right? Forget gate information, according to that there is a w will call, will the weight by multiplying different weight, the which information to be weighted more or which information to forget, that will be dependent. So this is what the input gate, and this for the input gate modulation. So input gate equation is left side, and right side what equation is there, that is what the input modulation gate equation. According to this equation only, the performance or whatever the modification performance output will get here. So here the save vector usually called as the input gate, where the input is provided. These gates determine which information should enter the cell state or a long-term memory. And the important parts of the activation function for each gates, the input gate is sigmoid function, have the range of 0 to 1. This is what the input gate, this will called sigmoid function. And because of the equation of the cell state is summation between the previous cell state, and the sigmoid function alone will add the memory and not able to remove the forget memory. So here you can see this for the sigmoid function. Here it will be combine of both previous state data as well as the now whatever the input we are providing there. And one more thing is this whatever the input modification gate is there, right? Input modulation gate, sorry, not modification, input modulation gate, that the function which it takes is the tanh function. Here you can see why we are using a tanh function, because it has the range of between -1 to 5, which allows the cell state to forget the memory. That's why we'll use the tanh function there. And this one is the output gate, the below is the equation of the output gate. And the right side one is the hidden cell, hidden gate or hidden cell, you can call the, this is the function of that hidden state. So here the focus vector is usually called as the output gate, where we can get the output, and output of the all possible values from the matrix, which should be moving forward to the next hidden state. So from one output to another hidden state, if the output is moving, will be depending on this output gate. And the working memory usually will call it as hidden state, what the information to which information we should pass to the next sequence, which all dependent on this or which will be stored in this hidden state. So that's the deep like a brief info, like brief understanding of that LSTM architecture. Next we'll see what are the advantages of LSTM. So it has been so designed that a vanishing gradient problem. So this is one of the important advantage of LSTM, that is gradient problem, which is which will be available in some of the RNNs or different neural network model, which is now completely vanished in this LSTM. And when you do this also, there the model will not be altered. That is one of the advantages of LSTM. And a long time lags in certain problems are bridged using this LSTM. So there will be some time lags will be in the some neural network, that problems also like overcome using this LSTM. So it can handle noise, distributed representation, and continuous values. You can handle a different type of these data. So with LSTM there is no need to keep a finite number of state from beforehand as they required in HMM, we'll call it a hidden Markov model. In that case, there is we need to keep a finite number of state like beforehand only. But in this case, LSTM we need not to do that one. And LSTM provides us a large range of parameters such as learning rates, input and output biases. Hence, no need of a fine adjustment. We need not to like fine tune any parameter here. And the complexity to update each weight is reduced here. You need not to update each weight here, similar to that of a back propagation through time, which is an advantage of LSTM. So these are the different advantages of LSTM network. So finally, we'll see what are the application areas or where we can use this LSTM. First one is in robotic control, robot control, time series prediction, speech recognition, rhythm learning, music composition, grammar learning, handwritten like handwriting recognition, human action recognition, sign language translation, protein homology detection, predicting subcellular location of proteins, time series anomaly detection, stock price prediction, and several prediction tasks in the area of business process management, in prediction in medical care pathways, semantic parsing, object core segmentation, airport passenger management, short-term traffic forecast, drug design, market prediction. So these are the different areas where you can use LSTM to predict these things. So these are the different applications of LSTM, and this is the like brief introduction or explanation about this long short term memory neural network. So thank you for watching the video. Thank you.